Let's have a look at the basics. When we think about exponents, we think about the basics like squared, cubed, and power 4. You should always have one of these tables handy when you're working on this topic because you need to know what are perfect squares in the first column, perfect cubes in the second column, and degree 4 quartic roots in the third column. So with that in mind, let's keep going. Let's review simplifying radicals. Remember, we always keep the index with us with our questions, and the first thing we're going to do is think about, if this is a perfect square, what are some numbers that we can use to simplify this question? So if we take the square root of 25 and the square root of 2, because remember, we can break 50 into two numbers, 25 and 2. So what is the square root of 25? 5, and the square root of 2 is the square root of 2. Let's look at the next question. Well, think about the factors that are perfect squares, and if you get 36, great job. So we can split everything up into groups, our 3 groups, and that's supposed to be an x squared. And the square root of 36 is 6. The square root of root 2 is simply root 2, and the square root of x squared is x. A lot of people ask me, does it matter which order you write these in? No, it doesn't, as long as the components are the same. Let's work with some questions that are in higher degrees. So notice our indexes are now 3s and 4s. So instead of using the first column, we're going to now use the second column. So what is a perfect cube? That's a factor of 24. Well, if you think about that, that would be 8. And 8 times 3 is 24. And now we simplify. What is the cubed root of 8? 2. And the cubed root of 3 is the cubed root of 3. So that's how we simplify. It's the same process, the same patterns. We're just using a different table, and we're just using a different index. All right, next one, a cube root of 192x cubed. Well, that's the cube root of 64 times 3, and the cube root of x cubed. The cube root of 64 is 4. You can refer to your table for that. Cube root of 3, and the cube root of x cubed is x. Let's play with the fourth root. Well, now we're looking for things in the table of the third column. 2 times 2 is 4, times 2 is 8, times 2 is 16. So the fourth root of 16 times 2 would give you 2, index 2, 2. And the fourth root of 1,250, I know it's a big number, but if you notice in your column, 625 is the fourth root of 5. So it's 625 times, error. This should be a 4, sorry. Times 2 would give you 5, the fourth root of 2. All right, let's throw in some variables. So let's split these all up. Again, just using first round. Now, if you know the trick, you can split this up into y cubed and a y. Now, what about 40? Well, let's think about our perfect cubes. 2 times 2 is 4, times 2 is 8. 8 times 5 is 40. So this can be 8 and 5. And this simplifies to x. This simplifies to y. And this stays as the cube root of y. The cube root of 8 is 2. I'm going to put the x and the y here. And remember we talked about if these are with the same index, it's undoing the multiplication rule, we can put them back under together. So the answer to the cube root of 40x cubed y to the fourth is 2xy and the third root of 5y. All right. Okay, same idea with the fourth root. So let's split this up. Fourth root of 162. And we know by now that the fourth root of x fourth is x, so maybe we'll save ourselves a step. And the fourth root of y fifth will be y fourth root of y. Okay, let's think about 162. I think 62 is the fourth root of 81 times 2 xy fourth root of y. And the fourth root of 81 is 3. Let's put these together. So we get the fourth root of 2y, and we still have our y outside. So there we have it. That's how you simplify questions in degree 3 or degree 4 with variables. All right, let's look at this slide. This is a way to get from mixed radicals to entire radicals. So what we're going to do is keep the structure with our same index, and whatever is on the outside is going to get raised to the index times whatever is on the inside. As you can see, we have three questions here. The square root of 4 times 3, the cube root of 4 times 3, and the fifth root of 4 times 3. Now, let's tackle this question using the same method. For the square root of 4, we know that's 2, but let's apply the rule so we get the same pattern for each one. So what we're going to do is use the rule from the last slide, which said take what's on the outside and raise it to the power, and multiply it by whatever is on the inside. So now we have the square root of 9 times 4, which is the square root of 36, which is 6. If we go back to the original function and we ask ourselves, well, what is the square root of 4? Well, the square root of 4 is simply 2, and what's 2 times 3? 6. So we agree in the answers. All right, let's keep going. 3 times the cube root of 4. So again, we keep the same structure with our cube as our index, or 3 as our index. Then we take what's on the outside and we raise it to the inside and we multiply it by 4. So that's 3 times 3 is 9 times 3 is 27 times 4, which is the cube root of 108. All right, the next one. Let's look at the next question. Using the same structure, we'll use the fifth root. What's on the outside get raised to the index times 4. And 3 to the power 5 is 243 times 4. And all under the index of 5, we would have 972. So we've now gone through 3 examples of how to go from mixed radicals to whole radicals. I like to tackle the last section of this unit by going back and looking at power law, one of my favorite laws. So what we can do is we can take our power law and we can undo it a little bit. So if we remember, the rule says that we have to multiply them. So a times 1 over b is a over b. So if we split them up like this, we'll be able to use this usefully to help us solve the problem. Let's look at this notation, the square root of x notation, the cube root of x notation, the fourth root of x, or even the nth root of x. This notation isn't always convenient, so we have an alternate way of writing this, which is equivalent to this. So if we want to write the square root of x as a fraction, we write x to the 1/2. Same for cube root. It's x to the 1 over 3. Fourth root, you got it, x to the 1 over 4. And any root is x to the 1 over n. Let's add in one more exponent inside the radical. So now, instead of writing x to the 1/2, we add in the 3. So this is x to the 3/2. X to the 5 over 4, x to the 2 over 5. So notice that the index is always in the bottom. All right, so let's look at it if we get it into this fractional form. So we can say, well, let's go back and look at the power law and split this up and say, well, this is 8 to the 1/3 squared. But we already know that 8 to the 1/3 is the same way as writing the cube root of 8 squared if we go backwards. And the cube root of 8 is 2, and 2 squared is 4. So the 8 to the 2/3 is equal to 4. All right, let's go back again. 25 to the 3/2. Well, that's 25 to the 1/2 cubed. And if you want to write this as the square root of 25 cubed, you can do that. And that is 5 cubed, which is 125. 16 to the 3/4. Well, let's save ourselves a step here and go 16 to the 1/4 cubed. The fourth root of 16 is 2, and 2 cubed is 8. And the last question would be 27 to the 1/3 to the power 4. The cube root of 27 is 3, and 3 to the power 4 is 3 times 3 is 9 times 3 is 27, times 3 more is 81. So there you have it. That's all you need to know about exponents.